Good morning. Welcome to the lecture on binomial distribution 2. In this lecture, we are going to discuss some more examples. First example, a probability that a person aged 60 years will live up to 70 years is 65%. What is the probability that out of 10 persons aged 60 years, 7 of them will live up to 70 years? So the question is that a person of 60 years will be living up to 70 years, probability is 65%. So if we take the 10% of that age, that is 60 years, what is the probability that 7 of them will live up to 70 years? The solution, the random variable x, p, the number of persons aged 60 years living up to 70 years. As per the data, they have given 65%. So, probability of success, that is P, can be taken as 65%, that is 0.65. And we can determine the value of Q by using the formula P plus Q is equal to 1. That is, Q is 1 minus P, which implies Q equal to 35% or 0.35. And N is equal to 10. That is, 10 such persons are taken into consideration. As per the formula, P of x is NCx into P to the power x into Q power n minus x, which implies P of x is 10Cx into 0.65 power x into 0.35 power 10 minus x. Now the question is P of x greater or equal to 7. That is P of 7 plus P of 8 plus P of 9 plus P of 10, which on substituting x is equal to 7, 8, 9 and 10 and simplifying, we get 0.5138. So, coming to the next example, in a sample, large number of parts manufactured by a machine, the mean number of defectives in a sample of 20 is 2. Out of 1000 such samples, how many would be expected to have the defective parts? Mean number of defectives out of 20 samples are 2. We know that by binomial distribution, the formula for mean is n into p. Then we have n into p is equal to 2 and n is equal to 20. So we get the value of p as 0.1. Therefore, the probability of defective part is P equal to 0.1 and probability of non-defective part is Q equal to 1 minus P, that is Q is 0.9. By using the formula P of x is equal to 20cx into 0.1 to the power x into 0.9 to the power 20 minus x. To find at least 3 defective in a sample of 20, that is P of x greater or equal to 3 is given by complement of that is 1 minus P of x less than 3. That gives us 1 minus P of 0 plus P of 1 plus P of 2. This gives 0.323. Here we are not directly considering P of x greater or equal to 3. Instead, we are considering it as 1 minus of its complement, because when x is greater than or equal to 3, we need to have 3, 4 up to 20. It is very complicated. So we can use the formula and get the answer. To find at least 3 defective in a sample of 1000, it has to be multiplied with 1000. So we get 323 as the answer. Next, example 3. In 800 families, 5 children each, how many families would be expected to have 2 boys, 5 girls, either 2 or 3 boys, assuming the probability of boys and girls are equal? Solution. Given probability of boys and girls are equal, that is P plus Q equal to 1, which implies P equal to half and Q equal to half. Since a family consists of 5 children, n is 5. As the formula says, P of x is n cx p power x q power n minus x, which implies P of x is 5cx into half power x half power 5 minus x. Since the bases are same, the powers get added. So we will be getting x and x cancelled. And 1 by 2 to the power 5 we get. That is P of x is 1 by 2 power 5 into 5cx. For a family consisting of 800, we need to multiply the answer with 800 in order to get the required data. So, formula is changed by multiplying 800 with P of x. That is 800 into 5cx upon 2 to the power 5, which on simplification we get f of x as 25 into 5cx. Now, the first question is probability of having 3 boys in the family. So, when we substitute x is equal to 3, we get 25 into 5c3, that gives 250. Next, f of 5, which gives 25 into 5c5, that gives 25. Next, f of 2 or 3, which gives f of 2 plus f of 3. That on simplification, 25 times of 5c2 plus 5c3, which gives 500. These are the number of people for the required. Thank you.